So now that we've created virtual machines, let's take a look at some of the tasks involved in configuring a virtual machine. So in this case, I've got a VM running. What are some of the things I can do or might want to do to actually change or modify or just generally configure that VM? And we'll start with what is often the most common question that IT pros ask when they're new to Azure, and that is, how do I modify IP addresses? Well, to understand this, you got to realize there's two kinds of IP addresses: private IP addresses and public IP addresses, and they are what they sound like. A private IP address is an address used within a virtual machine to communicate with other virtual machines that are in that same Azure network. So if you, for example, RDP into an Azure virtual machine and you run an ipconfig command, what you're going to see is the private IP address. So this would be your 10.0.1 or whatever custom address scheme that you choose. There are also public IP addresses. These are IP addresses that are accessible from the general internet and represent ingress and egress points for traffic going to and from your virtual machine. Now, any virtual machine can be assigned a public IP address, and public IP addresses are also assigned to things like load balancers and gateways. There are two methods of assigning IP addresses: dynamic and static. Now, these behave just a little bit differently than what you would traditionally think. A dynamic address is not a DHCP address. There is no DHCP in the way that we traditionally think about it in Azure. A dynamic address is an address that's simply assigned from the range of addresses on the subnet that the virtual machine is on. Now, it's allocated when the virtual machine is created or powered up, and it can change if it started or stopped. So it acts and behaves like a DHCP address, but it's not based on a lease. It's allocated when it starts up, it's deallocated when it stops, and it's pulled from the pool that is on the subnet. You don't have to create, for example, an address pool. If it's a dynamic IP, it simply grabs one from the subnet that the VM is assigned to. A static IP address, on the other hand, doesn't change. In the case of public IP addresses, they're released when the VM is powered off, unless they're static, in which case the same address is retained. For static IP addresses on the public side, you don't get to choose your IP address. You simply indicate that you want a public IP address. If it's okay that the public IP address change, you choose dynamic. If you want to retain the same public IP, you choose static. But bear in mind, you don't get to pick your address. That's one of the key things with Azure. They have a range of addresses that they can assign to resources, to these external endpoints as public IPs, and they're going to give you one. You have no control or no say over what that is. So let's take a look at how we go into an actual VM and configure and manage the IP addresses. Okay, let's take a look at how we can take a virtual machine and then just modify the IP addresses to switch them between static and dynamic, and also how we allocate and manage public IP addresses. So to begin, I've already deployed a virtual machine. It's a very simple, very basic virtual machine, basically using all the defaults. So we're kind of starting from, if you go in and you go to the marketplace, you pick a Windows or a Linux virtual machine and you just deploy it, take the defaults. This is essentially what you get. We'll start off with the fact that when this was deployed, we gave it a public IP address. And so there's an object in here called appserver-IP, which is the public IP address that's been allocated to this virtual machine. Now, the public IP address is dynamic by default. We can easily switch it to a static public IP address by coming into its settings, looking at the configuration, and then changing it from dynamic to static. And then if we want to, adding a DNS label. We'll click Save on that. And we've now switched that from a dynamic public IP to a static public IP, so we know that that public IP address is not going to change if we offline the virtual machine. For the internal IP address of the virtual machine, we're going to look at the network interface that was created when the virtual machine was deployed. So we'll click on the network interface, And its properties are going to open. And we've got a setting called IP configurations. We'll click on that. And we can see the IP configuration for this particular interface. Now, if we click on the IP configuration that's stored, you can see as well, we've got public IP enabled, and we can actually take, if this interface didn't need a public IP address, we can disable the public IP, deassociate it here, or if we needed to change it to a different public IP address, for whatever reason, we can do that right here. So we click on the IP addresses and we can change the public IP that we're using. We can choose the subnet the virtual machine is connected to. We've only got one subnet, so we've only got one option. And it's by default a dynamic IP. We can then change that to a static IP. And then we can choose the IP we want, or by default, it'll pick up the dynamic IP that was assigned. So for example, I want this to be 10. I can simply change it to 10. Click Save. It'll now go make those changes. Once those changes are saved, we can come back and look and see that the configuration has kind of detected those changes and updated to reflect what the current statically assigned IP address is. And that's it. Any virtual machine you deploy, that's how you adjust any public or internal IP address between static, dynamic, and also enable or disable a public IP. Okay, next let's take a look at the concept of virtual machine availability. What are the tools available in Azure to govern and control availability? Within Azure, you don't have any control over which piece of hardware your virtual machines actually run on. Or do you? Well, the availability tools give you some say in how your virtual machines and your applications are deployed. And there are three major tools you have at your disposal. The first one is called an availability set. An availability set is a group of virtual machines that represent a unit that should be always available. So it's a way of taking, for example, an application to say that this application is a unit and needs to be treated as a unit. And that application becomes an availability set. It will make sure then that all components of that application stay online or go offline at the same time. You then have what's called an update domain. An update domain is if you're performing updates, revisions, applying patches, or rebooting, or for example, just generally updating an application, an update domain is a unit of the application that's updated at a single time. So for example, we have different cycles, weekly updates, or other types of updates. And then a fault domain. Any application that is in the same fault domain is going to make sure that those components are distributed across physical pieces of hardware. For example, if you have a cluster or maybe a two-tier application and that application is in the exact same fault domain, it's going to make sure that not all components are on the same location within the same data center. It's going to make sure they're distributed so that no one outage can take down your entire application. Typically, you would have multiple virtual machines at a layer. If those virtual machines are in the same fault domain, it's going to distribute those virtual machines across the Azure fabric to make sure that a failure in any one location will not affect all components. So it's a way of forcing them to be separated. You would have multiple VMs in an availability set. Application tiers would be in separate availability sets, and then you could combine this with load balancing to make sure that you equally distribute. And we're going to talk about load balancing in a later module, but to make sure you can equally distribute all the load across all the different physical locations and physical pieces of hardware within Azure. So let's take a look at how we create and configure availability sets. Let's take a look at the process for creating an availability set within an Azure resource group. Now to start, I've got a resource group created. There's nothing in it. The plan is to put a bunch of virtual machines in here that represent a multi-tier application. We have a web tier, which is going to have the web application, and a database here is going to have the back end. And so that's going to have a number of SQL Server instances in it. So we're going to go ahead and create two availability sets, one here via the console, or the portal, and one via PowerShell. So we'll click on Add, and we're just going to search for availability set. And it's going to bring us to the list of options, and one of them is a standard Microsoft availability set. which we're going to go ahead and click Create on. Now, I'm going to give it a name. Call this one Web Tier. And we're going to set two properties. One of them is the number of fault domains. And again, remember, the number of fault domains you can think of as the number of racks that all the objects that are assigned to this availability set are going to be spread over. So if I spin up 3 web servers, if I have 3 fault domains, I know they're each going to be physically separated. So something like a power failure or an equipment failure is only going to affect one of the 3 fault domains. And then I have my update domains, which is the number of virtual machines that can be rebooted for update or maintenance, are going to be taken offline for any sort of planned maintenance activity at any one point in time. The more update domains you have, the less the impact of a maintenance cycle would be. For example, if Azure were patching the underlying hosts and I had 10 update domains, I'm only going to lose 1/10 of my capacity during one of those update cycles. If I have 2 update domains, I'm going to lose 50% of my capacity during those update cycles. So the defaults are 3 and 5. We're just going to leave them at that. That's just fine. And we're going to go ahead and click Create. It's going to do a validation, and it's going to go ahead and submit the deployment for the update domain. Now let's go ahead and shift over to PowerShell and do our update domain, or excuse me, our availability set for the data tier. And so to do this, I'll first log on. And we're going to type a get Azure RM availability set, and we should see that in this resource group that we have one update domain. And so there it is right there. Here's our web tier update domain. Now let's go ahead and create the data tier update domain. New Azure RM availability set, resource group name, the name of the availability set, the location, and then our number of update domains, which we'll set to a similar 5, and our fault domain count, which we'll set to the default of 3. And so that submitted the job to create that second update domain. Let's go back to our portal, look at the contents of our availability set, and we'll see we've now got a data tier availability set and a web tier availability set. Within each of those, I've got 3 fault domains and 5 update domains. Now, to create a virtual machine and assign it to an availability set, it's simply a matter of just adding a virtual machine and specifying that availability set when you create it. So we're going to create a Windows Server 2012 Data Center virtual machine. And as I begin to configure it, we're going to be able to choose our availability set. Scroll down, and we can select our resource group, hit OK. Choose our size, again, standard stuff for creating a virtual machine. And then on our settings, we're just going to leave all the networking and storage for default. And we can see that we have the option to select an availability set, which is set to none by default. So we'll select that. And because this is our first web server, we're going to pick our web tier. Now again, I'd need to create more than one virtual machine to actually leverage this. So this works best with something like a virtual machine scale set, for example, where you've got multiple VMs, and it can make sure that as the application scales up and scales down, it honors the rules of the availability set to make sure that you have high availability in the event of maintenance updates or in the event of a power failure. Click OK. It'll submit this deployment, and we've now created that first virtual machine in an availability set. One of the benefits of using a cloud provider such as Azure is you have the ability to have an application or a workload scale up and scale down as demand needs or as demand warrants. The tool that you have within Azure to be able to do this is something called a scale set. Now, here's how a scale set works. I create, let me switch that to my pen for a second. I create an application. And within that application, I have, for example, web servers. And maybe depending on the load, my entire customer base out here in the world, so here's all my customers, maybe they could be served by 3 web servers. But because I'm an accounting firm and during tax season, I need that big spike, during tax season, I don't need 3 web servers, I need 30 web servers. A scale set allows you to automatically grow and shrink an application based on that demand. Let's say, for example, that there's a threshold here of, let's call it 40% utilization. So maybe, once we reach 40% utilization, we begin to see a performance degradation. And at 40% utilization, we want to start adding additional web servers. A scale set allows you to set a rule just like that. The input to a scale set is a virtual machine. The rules on a scale set say that at a certain threshold of performance, say 40% average CPU for 5 minutes, we'll go ahead and get bigger. We'll grow by adding another virtual machine. It'll measure it again. If performance is still above 40%, it'll add a third virtual machine until it reaches that acceptable threshold. Once performance drops below 40%, now let's say we're no longer at 40, now we're at 10%. It will start deleting these virtual machines to reduce your cost. So by implementing a scale set, you can construct a rule for performance and make your application bigger to handle greater load by simply automatically adding and removing virtual machines. You as the administrator have nothing to do once these rules are established. So to give you kind of a basic overview, they're implemented only for version 2 virtual machines, so only within the new portal, because they're built around ARM templates. They integrate with a couple of key tools. Azure Insight Autoscale that will measure performance and determine when to scale up and scale down, and also integrate it with the load balancer and with NAT. Now, the reason they're integrated with the load balancer and with NAT is because as we add these additional virtual machines, we're going to have a load balancer and a NAT device in front. As requests are coming in addition to deploying the virtual machine, we've now got to add the rule that allows traffic to be redirected to those new instances. So if this is, for example, on port 80, we need to add a rule to say, hey, there's more than one place on the inside that you can load balance to. The great thing about scale sets is not only do they add the virtual machines, but they also work with all other components of the infrastructure, including things like network load balancers, to make sure that in the case of a scale up, rules are added. In the case of a scale down, those rules are removed. Once you create your scale set, how do you kind of go in and look at it and kind of see how it's working or what the configuration is? With a scale set, you're not going to see in the portal lots and lots and lots of virtual machines. You're going to see one entry, which is the scale set. So how do you look at the configuration of the individual instances of the virtual machines running in the scale set? To do that, Azure provides a tool called the Azure Resource Explorer. It's a web-based tool. It simply looks into your subscription, and it allows you to drill down to a very, very fine level of detail so you can see literally every property and every value of every object you have in your subscription. allowing you to do very detailed diagnostics and troubleshooting. So in the case of this example right here, this is a scale set. It's got 10 virtual machines in it, and I can actually drill down using the Resource Explorer and look at, for example, what is the IP address on virtual machine 2. You can't do this via the portal. It has to be done through the Azure Resource Explorer. So let's go ahead and take a look at deploying a virtual machine scale set, scale up and scale down, and as well as using the Azure Resource Explorer. So let's take a look at an Azure scale set when it's being deployed and also when it's up and running, and just kind of get a sense of what we're dealing with here. Now they are a little more complicated than a typical VM deployment. There's a few more things you've got to think about, but fortunately we've got a number of quick start templates that make the process of getting started with this at least a whole lot easier. Now obviously as you deploy larger production worthy workloads, you're going to get into customizing these quite a bit and put a lot of time and testing into it. But for now, the quick start is a really good way of just getting started. And so we've got a template, which is number 201, that is what's called a LAMP stack, which is basically an Ubuntu Linux virtual machine with Apache and PHP. So it's essentially a non-Microsoft Linux-based application server. So we're going to go ahead and just grab that template and deploy it to Azure. So we'll take the easy way and click the deploy button. Now, when this deploys, you're going to see it's going to prompt us for a lot of different things. And then behind the scenes, the template takes care of deploying everything for the load balancer, for the storage accounts, for the networking, for the rules, and also for the different instances of the Ubuntu server. It's also going to configure the auto scale settings to allow it to both deprovision instances and add new ones as the load demands it. So this will go ahead and open here in the portal. And we're ready to put in the template parameters. So we're going to use just standard D1 VM. The version of Ubuntu is fine. We need a unique identifier that's going to be used to identify this particular set of objects across all the objects that it creates. So we'll just put in ch auto scale cjh auto 01, just so I've got a unique prefix. And we're going to start off with an instance count of 4, admin username and admin password. I'm going to do a new resource group. Call this one AutoScale 2. Pick a region. Agree to some legal terms, which I'm going to take the time to read very thoroughly. And we'll go ahead and kick off that deployment. Now, this deployment is going to take a little bit of time because we've got a lot of components in here. So let's go ahead and take a look at one that I did earlier. So we'll go back to resource groups. And I've got a deployment called AutoScale, which is an identical copy of what we'd done previously. Or I should say what we just did. So this deployment we kicked off, this is one that I ran. It took about 15 or 20 minutes to complete. So we can see here all the different objects it created. And I just want to point out the load balancer and also the storage accounts. And you'll notice that the virtual machines are not in individual VMs, but are rather in that virtual machine scale set object. If we click on that, we can begin to see some of the properties of that scale set. And right now we've got 4 virtual machines running. Now I've been running some load on this scale set just to kind of illustrate how it goes up and goes down over time. And we can see that by looking at the activity log. In the activity log, you can see a couple of key events, scale up events and scale down events. The scale up events are when a new virtual machine is added to the scale set based on the parameters that are defined in the scale set. The scale down is when a virtual machine is taken offline or removed. Now the beauty of this is that as you add new virtual machines, you need to do things like update your load balancer and update your networking rules. The virtual machine scale set takes care of that automatically, adding new rules and removing rules as they're needed. We can dig a little deeper into the virtual machine scale set by using something called the Azure Resource Explorer. And to get to the Azure Resource Explorer, we're going to go to resources.azure.com. This is going to automatically log me into my subscription and give me a way of looking at every property of every object in my subscription in a JSON notated format. So we can start digging down through and we'll look at our subscriptions. So here's my current active subscription. Here's my resource groups. Here's my currently running resource group called Autoscale. And I can look at, for example, my compute resources. So here's the virtual machine scale set. And we can look at all the properties that relate to it. And then here are copies of all the virtual machines. We can see that I've got actually 5 running virtual machines right now. I can click on any one of the virtual machines and, for example, look at its network configuration and see that this particular virtual machine has an internal IP address of 10.0.0.5. We can also come down under the network and look at our public IP addresses. This is the shared public IP address that's used by the network load balancer. And we can also see within the load balancer different bits of information such as the rules. We scroll down here, we can see, for example, here's our allow port 80 rule that allows web traffic to come in on the load balancer and be distributed to all the assorted web servers that are behind it. So that's a quick look at, how we create a basic virtual machine scale set from a template. Obviously, if you build these in production, the templates can get fairly elaborate. You want to make sure the image that you're deploying with the template has your application in it and has all the appropriate settings. Pretty straightforward otherwise.